Triceratops lived at the very end of the Cretaceous period, around 68 to 66 million years ago, during a time when the world was warm, lush, and filled with enormous animals. The land that is now North America was split by a massive inland sea, creating vast coastal plains, river deltas, forests, and flood-prone lowlands. This environment supported an incredible amount of plant life, and Triceratops evolved to take full advantage of it. It was not simply a large herbivore, but one of the most dominant and resilient animals of its ecosystem, able to survive constant threats from massive predators and harsh environmental changes. Triceratops had a body built for power and stability. Its torso was broad and heavy, supported by thick, column-like legs positioned directly beneath the body. This structure allowed it to carry enormous weight while remaining balanced and steady. Unlike animals built for speed, Triceratops was built to stand its ground. Two long horns projected forward from above the eyes, while a shorter but thick horn extended from the nose. These horns were not ornamental. They were solid bone cores covered in keratin, making them strong, sharp, and capable of withstanding massive impacts. A full-grown Triceratops could easily gore, lift, or impale an attacker with a well-placed thrust of its head. Behind the horns rose the massive frill, a broad shield of bone, extending backward over the neck. This frill protected one of the most vulnerable parts of the body from attack. A predator attempting to bite the neck would instead strike thick bone. The frill also served as an anchor for powerful neck and jaw muscles, increasing both head strength and bite force. Over time, the frill evolved into a highly variable structure, with differences in shape and size between individuals, suggesting it played an important role in identification and social signaling. The face of Triceratops ended in a sharp, parrot-like beak capable of slicing through tough vegetation. This beak worked together with rows of teeth arranged into dense dental batteries. Each tooth was replaced continuously, ensuring that Triceratops always had sharp, functional grinding surfaces. This system allowed it to process enormous amounts of fibrous plant material every day. Triceratops could eat plants that were too tough, woody, or abrasive for many other herbivores, reducing competition and allowing it to dominate its feeding niche. Feeding behavior likely involves slow, deliberate movement across floodplains and forest edges. Its powerful jaw muscles allowed it to crush and grind food efficiently, extracting maximum nutrients. The digestive system would have been large and complex, capable of fermenting tough plant matter over long periods, similar to modern large herbivores. Social behavior in Triceratops was likely complex. Fossil evidence suggests that juveniles may have lived in groups, while adults could have been solitary or formed small herds. Group living would have provided protection, especially for younger individuals. A group of Triceratops standing together, heads lowered and horns facing outward, would have formed an almost impenetrable wall of bone and muscle. Predators approaching such a formation would have faced extreme danger. Young Triceratops looked very different from adults. Juveniles had small frills and short horns that curved backward. As they matured, the horns lengthened, thickened, and rotated forward, while the frill expanded dramatically. This transformation likely served as a visual signal of maturity and strength. Adults with fully developed horns and frills would have been recognized instantly, reducing unnecessary conflict within the species. Combat between Triceratops individuals likely occurred, especially between males competing for mates or territory. Fossil skulls show healed puncture wounds and damaged frills, evidence of horn-to-horn clashes. These battles were probably ritualized rather than lethal, allowing individuals to test strength and dominance without constant death. The frill would have absorbed impacts, while the horns locked and pushed against one another. The most famous interaction involving Triceratops was with Tyrannosaurus rex. Fossil evidence clearly shows that these two giants fought each other. Bite marks on Triceratops frills and healed injuries on Tyrannosaurus skeletons indicate repeated encounters. Triceratops was not passive prey. A charging Triceratops could seriously injure or kill a Tyrannosaurus if it struck the legs, chest, or abdomen. For Tyrannosaurus, attacking a healthy adult Triceratops was extremely risky. When threatened, Triceratops likely adopted a defensive posture rather than fleeing. It would lower its head, angle its horns forward, and brace its legs. This posture maximized protection and made it nearly impossible for a predator to approach safely. The thick skin, heavy bones, and muscular body provided additional defense. Triceratops was a living fortress, capable of standing firm against even the largest carnivores. Communication among Triceratops probably involved a combination of visual displays and sound. The frill and horns would have been highly visible, allowing individuals to signal dominance, aggression, or submission from a distance. Vocalizations such as low bellows, snorts, or grunts may have been used to warn predators, communicate with group members, or maintain contact in dense vegetation. Reproduction in Triceratops likely involves seasonal breeding. Females would have laid eggs in shallow nests, possibly in protected areas near water and vegetation. While direct nesting evidence is limited, related horned dinosaurs show signs of parental care. Adults may have guarded nests or remained nearby to protect hatchlings during their most vulnerable stages. Triceratops grew rapidly, reaching massive size within a relatively short time. This rapid growth reduced the window during which juveniles were vulnerable to predators. Bone studies show that individuals experienced injuries, infections, and diseases but were often able to survive and heal, indicating strong immune responses and resilience. As one of the last dinosaurs to exist, Triceratops thrived until the very end. It did not slowly fade away or become obsolete. Instead, it remained abundant and successful right up until the asteroid impact that caused the mass extinction. Its sudden disappearance was not due to weakness, but to a global catastrophe that reshaped life on Earth. Triceratops is one of the most important dinosaurs in scientific research. Thousands of fossils have been discovered, allowing scientists to study variation, growth stages, behavior, and disease in extraordinary detail. This wealth of information makes Triceratops a key species for understanding dinosaur biology as a whole. In life, Triceratops would have been an awe-inspiring animal. Massive, horned, and powerful. It was not merely surviving, but dominating its environment. Its presence shaped plant communities, influenced predator behavior, and defined the ecosystem it lived in. Triceratops represents the peak of defensive evolution among herbivorous dinosaurs. Rather than fleeing or hiding, it evolved to confront danger head-on. Its horns, frill, strength, and resilience made it one of the most formidable animals to ever walk the earth. Through Triceratops, we see that survival in the prehistoric world was not only about speed or aggression, but about strategy, strength, and adaptation, perfected over millions of years.